The intriguing new novel by John Grisham, America's favorite storyteller, brings science and mystery right to your door.
All right, so we finished the second exam, right? And we're heading to the chapter 9, which is the last chapter. We're gonna finish it in 2 lectures, and then after that, we're gonna have the final exam review and the final exam. Okay. Any questions?
I really drew a blank at some point. Did you grade these yet, Professor?
I haven't really. I am pretty busy planning out all of this and a practice final exam, so I haven't really looked at it. But I look at yours, and you seem to be playing a lot of questions. Right.
Yes.
So I will be grading it, and let's see what happened on the final exam. Okay, if you do well on the final, that's gonna be the chance that I'm gonna do something for the second exam. But if you do worse than the second exam, then I cannot do anything with that.
Oh no, we're gonna do better. I'll do better.
Yeah. So yes, you have another chance to do the final exam. And of course, this is the case where we are going to, get the grade from. So remember, the final exam will be 35% of the final.
Yeah.
Yeah. So it's almost like it's almost like the half, almost like twice of the first year exam. And also, I haven't really planned out the final exam review, but I did it for another class, for another section. So what the practice final looks like, so let me just show you what it is. And so this is what the practice final. Oops, I actually go in. So the practice final exam should be something like that. I haven't really finished it, but I'll be doing so relatively quickly for that, because since I haven't finished. So this is what the practice final exam looks like, and you click on it, and so I haven't finished that planning, but I will do so. So you click OK. That's pretty much the same thing that we have for the exam to practice, but it might be a little bit different. For this part, I do not mess up the question. It will be having the exact same order. But so let's say the practice final exam, the question number 1, the computer sample standard deviations are the following data sets. So this is what we learned before, a computer mean, the medians, all kind of things. Okay, so it doesn't count towards the point, but again, if you did not do well on the second quiz, and this is let's say a third quiz, whatever it is, and those gonna replace the lowest grade. For the second exam, and how many people did not take a second exam? Okay, so all of you took the second exam, so that was pretty awesome. For those of you who started for late because of a certain situation that you cannot take it, okay, you have to email me. And for those of you who are doing really badly on the second exam, okay, so I would consider doing something for that part, but I'm not gonna let you know what it is. If you do well in the final, because the final exam is actually more important, okay, so it's more important for that. So if you're not doing so well on a second exam, so this is a chance. This is your chance to make up the point, and also I will do something for the degree that you have received for the second exam.
I will take it.
You will take it, right?
Yes.
Okay.
Yes.
And
So how about if you do so well on the second exam, but not the final exam?
then I cannot do anything because the final exam is more important than the second exam. Yeah, so I mean, if you do well on the second exam, you do so well on the second exam, but you messed up the final. All right, so that 35%. I mean, it's impossible for you guys to fail the final exam if you actually did well. So for example, just practice these questions. The final exam will be very similar to that, except for the fact that I might just change a certain type of question, like the numbers or the wording for that part, and those stay the same on the final exam. But you gotta be careful when you practice, okay? So for each topic that we do, I'm gonna highlight the keyword, the topic for each chapter. But on the final exam, I won't for sure. You make sure that you practice enough for the practice final, and then you should be able to do well on the final exam. So this is all I can do for the conversation. I got one person's the student. She emailed me saying, "Well, I need to watch my nephew and during the exam time, so I do not really have enough time to finish it." No, do not say that. So I give you 24 hours. You can start the exam anytime you want to. State it from 8 a.m. until 8 p.m. So 12 hours. You can pick any time that people want to sleep, and then you can start working on it. So there's no excuse saying that I can't take the exam on that specific time because I haven't wake up yet, or I don't tell me like that. So we have to finish it, but it's pretty much the same thing. Like pretty much I only have planned out to do 3 questions. I just want to test on a few trial. And when I see the question, I will need to check them out real quick. Okay, and then this is going to show me the result after I took the practice final exam, and we'll be done. So okay, so regarding the final exam schedule, so you have choices. Either you can take it on 19, or now you can take it on 21st, May 21st. What do you think?
Oh, is that for the whole class to decide
For the
or
whole classes?
individually?
Yeah, we're not going to see each other. Remember that we're not going to see each other again on Zoom or anytime, okay, after the final. So we have choices. You can take the final exam on May 19. I believe the sooner the better. The later the worse. So I can grade your exam and let you know, tell you the grade, or you can basically email me. Okay, so after the final exam, let's say I'm very worried about a grade. Can you grade that? Can you grade my final exam first? I would do so. Okay, but for the grade posted on June 1st, you have to wait me for a moment until I can grade all of the classes, and then I do certain things, either going to maybe some people who did so badly on a third exam but did really well on a final exam. I might do something for that, or someone did really badly on a second exam but do really well on a final exam.
Go to my bed and get my
But not
headphones.
the other way around. Not the other way around. Remember that if you did worst on a final, this is what you have. So I told you before that the final exam.
But Professor, do you have grade the second exam already?
I haven't really graded. In fact, your advisors actually emailed me concerning about your grade, but I haven't really responded back.
So how many questions is in the final exam?
So let's say the final exam will be total 8 questions. Each question going to be like 4 different parts. So you should expect to see around 30 questions for that. So remember that wouldn't make up the exams on. Remember, if I make up the exam on Blackboard, I can only make up one section for that part. Right? Remember that I cannot do both of them. Okay. So
So giving us a couple of hours for that. 30 questions. That's a lot.
Yeah, because for the other exam, I finished it in almost about 3 hours.
It's almost 3 hours. So I'm gonna give you guys around 5 hours for the final exam. Is that fair?
I have a couple of questions. One, we don't have to show the work, do we? Or do we have to do it the same way we did the last exam?
Yes, you have to show the work for that part.
Oh, okay. So we will need a
Let
bunch
me
of time.
expect, for example, question number 1 asking us to do the mean, median, standard deviation. So 3 questions already, right? And then question number 2, you have to do 1 and 2. So 2 questions, 5 questions. Question number 3 about chapter 5, and then there'll be A, B, C, D. So each A, B, C, D going to be 4 questions, right? I mean, 1 question will be 4 different questions for that part. So it's a little bit more challenging for me to make up the questions on Blackboard, but this is how I make the class fair and good enough. And
Miss Kim, you
similarly,
said,
for question number 5, there'll be 2 part A and B. So that'll be 2 more questions. So that would be, 11 questions already, right? So I mean, but the fact is, we don't necessarily get like 30 questions. Well, it should be around 20 questions, but each question will be one single part. You're not going to be like one question A, B, C, D, right? One question, one part. You just need to put down the answers and show me the work how you solve that. And that's it. You move on. You're not going to come back again and see, hey, do you have to do part B and part C? Okay. So the reason behind that, because I felt like for some reason, I made the exam and people just did part 1 and then they forgot part 2 and vice versa. So this is Blackboard can clearly see that actually people working on each part separately. So you can't skip the question. So I mean, there's no way that you can skip the questions for that reason.
excuse me, sir, 2 questions.
Yeah.
2 questions. Number 1, the first one, sorry. Do we have to write out the questions or we can just show the working? We don't have to write out the question, right?
I don't think that you need to write down a question. So on the second exam, final exam is basically in the exact same order. So we don't really have to write down a question. I mean, the difference would be each person going to receive different numbers and different for that part. But we should get the exact same order. And you just do the question, but try not to do like question number 1 and then jump to question number 11, come back to question number 6 and go to question number 17. I mean, you're going to drive me crazy. So your grade will also be crazy as well. I'm just kidding. Okay.
Okay. So,
right. So just put down like the first questions and then question number 2. If you get stuck on question number 2, you're going to leave some space, maybe 3, 4, or 5 lines, depending on how big up your letter is, how big up your handwriting is. And then you keep going. You keep going until we finish it. So that way it helped me save a lot of time when I grade the exam, since we do not have the paper like the exam like that. So that would be great if you guys just do so. Can we decide on the final exam day? So
we can go back though in the final exam, like
yeah, you can go back on a final exam for sure. So you don't have to. And sometimes you don't really have to put down the answers, but putting down the answers is going to help me a lot. Because let's say you did not show me the work. I'm sorry, you showed me the work and then you got the answers, but your work shown doesn't really give me the final answer, whatever. But I look at it, you put down a final answer right there. So I check them, I check your work, that matches, give you full points, very easy. Right? So yeah, so that's pretty perfect for that. But if you forgot to put down the answer key, let's say I forgot to put down 0.85, whatever it is, and then you just move on and forgot to state the answer, that's fine. That's perfect. That's perfectly all right. Just make sure that you show me the work the point. The answers for each problem does not work the point. So making sure that we understand the situation. So when we'll be on a final exam, and Charlie just asked us the question, so we would like to have the final exam on May 19. Do we agree?
Yeah, so like that it's fresh in our minds.
Yeah, so that's going to be a lot better for us instead of having the final exam on May 21st, meaning that you have to memorize stuff until May 21st. We don't want it, right? The sooner, the faster that we can get rid of material anyway. So this is pretty much the thing, that you make sure that you need to remember all the step, all the strategy that we've done until May 19. For the time being, we're going to finish.
So the final exam will be in the 19th?
Yeah, we'll be on the 19th. I mean, our official schedule is on May 21st, but I can make this flexible because I do not want to make the final exam. It take me so much time to do so. But since we are in a very difficult situation where I have to make it a final exam for us. And so the final exam again, that will be on May 19. So do you agree that I'm going to push the final exam on 8 a.m. in the morning? And you can't do so until, what do you think? I can put it on 6 a.m. in the morning. It's up to you. Whatever you want. I can make it available from 12 a.m. in the morning up to 12 a.m. on the next day. what do you think? I mean,
I
11.
think like 24 hours, like you just said.
Yeah, 24 hours. So that I would make it available at 12 a.m. in the morning. I'm not sorry. Yeah, 12 a.m. in the morning on May 19 up to 12 a.m. in the morning of May 20. Is that good?
Mhm.
Yeah.
All right. So once you start it, you have to finish. I'm timing it. So remember that this is just a practice exam. There's no time shown on this section. I mean, even allow multiple attempts, but remember we only have one attempt to go to the question. If your internet connection is not good enough, please do not start it. If your internet connection is good enough, you can start it anytime you want until.
Yeah, that's what happened to me last exam.
So I mean, you can save your work. I mean, you can save your work, and then you come back to it. And so let's say you say the work, and once you start the questions, and they do not come out the same number, because each time that you go back to it, you're gonna get different value for that part. So just stick with one single value that we have. Let's say I captured the questions on that attempt, so I just do so. Because when you come back to the question, you might get different answer for that. Okay, so just write down the number that you have. You don't have to write down the entire questions on a final exam. Just write out a number. Let's say 51% of the member retire. You put them down probability of 51% of it retire, and 39% male. So you put down probably a male. You code you 39%, and retire and man. So that would be 11. So would be join. And then I want to figure out the either or. So I just add up two big and subtract the small. Let's for example, so I can put 51 plus 39 minus 11%. And then so I don't really have to come back to the questions. And once I come back, I might get different value for this part. So in this case, we're the same, but I don't know. Usually when I save it, I do not submit them for examples. And when we come back to the question, you might get different value, but usually the same value. So because we only have one attempt, so making sure that the connection should be good enough to when you start it. Remember, you cannot have the connections locked up for like 24 hours. If you have that issue going through, let me know. Okay, so the CUNY administrators going to help us out. And what's going on for that part is that if you have a friend who's taking my class and he or she does not have a laptop or computer or Wi-Fi connection, let me know. Okay, so I'm gonna forward to the CUNY system, so they're going to help us out, and they can loan us a laptop, or we can basically call the number to get the Wi-Fi, the free Wi-Fi for the entire semester. I mean, I would say up to June, something like that. Okay, so and this is the case. So making sure that we have all the Wi-Fi connections and the laptop available before the final exam. So that's being said, I'm sorry. Uh, Um, that's being said, if you if you don't have enough time, you can save your work, but again, that when you start it, you have to finish it in 5 hours. So you can't just say your work and take a nap for 10 hours and then come back to the question, it's expired, right? So you have, let's say I'm so sleepy, so I do not want to start the exam. So just have some good sleep. You wake up and then you open the test and you do it. And you finish it in 5 hours. So I feel like that's going to be long enough for us to finish every exam.
Mm,
Will we be able, when will we start reviewing for the final?
Once we start reviewing the final exam. So let's say we finish chapter 9 on April 30, and so that'd be the last day of April, and then we come back on May 5th and May 7th. So those 2 days, I'm gonna give some practice final exam. Okay, and besides the practice final exam that I give on this page, those practice final exam is in PDF file. So I post it on Blackboard. There will be 2 practice final exam, and I'm going over each questions. And after that, we're gonna have some practice final exam on a computer, so I can get you to the version that you see on Blackboard. So when you get on the Blackboard version, we don't get shocked, right? And we do that, and after that, until May 18. I mean, you can try as many attempts that you want, so I don't care if you can try 10 different attempts. I grade the last one. So let's say the final exam that you're doing not so well. I got 65, or maybe lower, whatever lower than 70. So I'm gonna add 5 points if you do so. Okay, so let's say I did question number 3, question number 4, 5. I did everything. So I did a pretty good, really good on the practice final exam. But I'm not doing so well on the final exam. I got 62, for example. So I'm gonna add 5 points if I can check the result that we have right there. So I can check the result on this part. And so if you score less than 70, I'm going to add 5 points to it. However, for those of you who, let's say I got 85 on a final exam, so there's no reason that I add point. So for those of you, but however, for those of you who do the practice final exam, so let's say I did not so good on the first quiz, what should I do? I'm gonna drop the lowest one and replace by the grade that you have on the practice final exam. Is that fair? So let's say I forgot to do quiz number 2 because I was busy, I was sick. All right, so we have 5 quizzes in total. And if I see that you did the practice final exam, I'm gonna take that quiz number 2. I dropped it, and then I'm going to give you the point that you have on the practice final.
And when will you be finished grading the last exam?
When I will be finished grading that, usually over the weekend. And I feel like I mean it's not about work, it's about downloading all the files, right? So the grading is really straightforward. I just grade right here. I have the full grade standards, and remember the grade will be shown not on this leaf. Who cares? I just did the practice final. I got 30 out of 30. That's fantastic. I'm just kidding. All right. You can see my grade right there. That was so amazing. Okay, I'm just kidding for that. So again, you're gonna get the grade on this folder. You're not gonna get the grade on the exam. I mean, if you want to get it, just put it down. It doesn't matter. But this is where I grade your exam. So you're gonna get the grade on this exam too, right? So I'm gonna put the grade on submit exam 2 work here, right? So you're gonna receive the grade by this weekend. Okay, so I feel like that's
Okay.
pretty much it, right? So that's fair. That's basically the things. And there will be one more classwork on classwork number 17. And for Miss Classwork, for those of you, I know some of you were sick, some of you was busy taking care of your personal issue, whatever it is. I do not put down a deadline for this classwork, okay? You can still finish it. For those of you who missed the classwork, let's say, certain class where I don't know. I mean, 5, 6, whatever it is. So just do it. Just do all of that, and I might drop the lowest. I might drop the lowest 3. Okay. So the classwork. How many percent on the classwork? 10% is correct. Is it? Yeah, that's a lot of points. So some people were saying, "Well, I got 60 on the second exam, but I did really well on the final exam, and I also did most of the work, so you still get a pretty decent grade in my class." So, but again, the second exam 20%, the final exam is 35%. So your job is try to get those points so that we don't really regret what we're doing. So this is the thing that we need to do. For the lectures, again, that the lecture will be on chapter 9 right there. You remember all of these videos that I posted, including the lecture notes. I actually have your file on my YouTube channel, basically. So if you want to read for that channel, you can just go over all of this. So chapter 8, that we're going to have 3 different parts, and then we also have the exam 2 review, video as well, and also chapter 7 that we have um, the the lecture notes. So if you want to view, I'm not sure if you guys have no time to check because those videos are pretty long. It's captured the entire class sections, and sometimes I got disconnected from the Wi-Fi, so it might be a little shorter. I don't know. So for the chapter 6, there's no material for that part, and for the there's no video either. But what's going on for that is we're gonna have to finally review video so you can watch it again. Just watch it and watch it again, and then do some practice for the final exam. You should be doing really well. You should be doing really well. If you're still not doing well, so what's going on for that part? If you still don't have the confidence to do well on a final exam, what's going on? So we're gonna have class until May 7th, okay? But I'm gonna give some time for us to. So this is May 12th will be officially the last day of class. Usually we don't have class, so this is more like the reading day or the review day. But I will be here. I will be here. I will be here answering whatever the question that you have. You don't have to be here. I'm not going to do anything on that day. I'm not going to collect work. I mean, the work you can submit it on Blackboard until we finish it. Remember, so all the classwork that you submitted should be done by May 19th. You can't really. I'm going to close all of this file on May 19th on that day. So for some personal issue, I got some of you actually working really hard, and if you haven't finished it, please do. I actually finished grading, right? How many of you who received the grade of the classwork? Most of you, correct? So yeah. So if you receive
Yeah, I received most of the classwork, but for quiz number 3, I didn't receive my grade yet.
oh, you didn't receive your grade yet, probably because I haven't. I think I left up. I mean, the hard part of this is unlike the paper, right? You have to go through every single corner, every single section of that.
Yeah, because I think I've only been graded till chapter, to classwork 13.
To classwork 13. Okay.
Yeah, it's the only ones I see grades for.
Oh, that you get a grade for. I haven't received any grade yet, so you should get the grade. You go into the tool, and then you go to my grade, and then you can see that the list of grade. I actually did one practice final exam. I actually got 30 points. All right, so I just want to check if the work done, if the calculation that it did was correct using the Blackboard format. But generally, that we should receive all the grade from quiz 1, 2, 3, 4, and up to classwork number 16, correct? If some of you still haven't finished it, because I want to wait out for people who haven't finished that to grade. But usually over this weekend, I'm going to finish all the grading. I'm going to finish all the grading on that.
So will you be double checking, right, to make sure we all our assignments were accounted for and graded and stuff like that, right?
Yeah, so the 3 lowest classwork will be job, but this is the best I can do. Okay, this is the best I can do.
So you said that you did it up to classwork 16?
Up to classwork 18. There will be 2 more classwork left out, but yeah.
Because I think I did all my classwork, but I didn't receive some of the grades for some of them.
You haven't received all the grade. Okay, so you have to give me some time. I mean, it's not easy. Yeah, so I will try to upload it. So when we come back on Thursday, there will be quiz number 5. That will be the last quiz that we have, and the classwork numbers 17 and 18. So take your time to do so. Take your time to do so. And after that, we come back on May 5th. Okay. We come back on May 5th and 7th. So we're going to have 2 final review. That's it. We're going to call it, we're going to say goodbye to each other. Or maybe on May 12th, I'm going to see it again. So for those of you who are willing to come and ask me a question, I would answer all the questions that you have. I would answer all the questions from the practice final exam that you have. I would answer all the questions concerning the work, okay, not the personal questions. And after that, we're gonna wait out until next Tuesday to take the final exam. You can't take the final exam at 1 a.m. in the morning, but please do not do so, right? So you have enough sleep, and when you wake up, check the Wi-Fi, making sure that it worked properly, and start working on the exam. Make sure that you have calculator. You can use this guy, or you can have the table. You can use this chart, and we can have pen and pencil and a paper to write that'll work, and take a picture of that. So, no, it quiz file will be on chapter 9 only. Okay. And that's again that you can check your grade using tools. I don't have the grade yet, of course. I do not have the grade except for that one. I want to check the practice final exam, but I'm gonna rewritten it. So there will be so many things that I haven't really. I mean, I have to plan a practice final exam, which I usually don't do because I have all the practice final for our class. But since I'm doing it for both version, one on Blackboard version, another one on PDF version. So there's no way that you blame saying, well, I do not do well with file. So try your best, okay? Just take the notes. So let's say I forgot what it is. You can go to lecture notes and then you can review it, right? So all of these notes available, right? You take advantage of that. So the lecture note, so chapter, on any specific date, and they can go back to the note, and then all these images going to help us out. Remember, the lecture note is basically right there. So you can click and check and, get it done. So now we're going to go to the last chapter, okay? So remember that we only have one chapter left, and we're going to see each other again for 4 times, including today. And then we're going to say we're not going to see it again, right? And then, again, once you do the final exam, making sure that you have to go to your assessment, and then you click on it. So practice final, and then final, and then submit work for the final exam. That's pretty much the thing that we need to do. Okay, so let me just check this part. And this is what we have for the practice. And this is what the chapter summary looks like. Okay, so I have been lagged out a little bit for some reason. All right, so that's pretty much the thing. So what is chapter 9? So this is the chapter where we have to deal with the hypothesis testing. So this is the first chapter, usually the first hypothesis chapter in statistics, but will be our last chapter. Why is that? Because we're doing elementary statistics. We do not develop a lot of, the concept is right there. The concept is working out for any hypothesis testing that we did. So when you read the report of any statistical report saying they make some assumptions, hypothesis, right? Hypothesis meaning we're making assumption and then we're trying to test on that. So this is basically on statistics. Usually all the report, let's say we want to test on people who have the COVID-19 on the street, for example, so they use exactly the same format that they did, and they basically produce a more effective way of computing those numbers. But what I'm saying is that the hypothesis testing is play a key role in statistics. So the reason why this is so important, because we try to utilize that to test on a population itself. So the whole point of hypothesis testing is this. It's basically similar to chapter 8. And if you ask me what the difference between chapter 8 and 9, chapter 8 is where we set the range for the population mean, right? So we don't assume any number for that. We just use a sample to figure out the range for the mean. So let's say on a final exam that I expect us to have the final exam between 78 up to 85, okay, up to 85, right? So this is what the chapter 8 looks like, right? So what does that mean? So for example, this is what I expect us for, not us, for the entire business campus, saying that the final exam average should be between 78 and 85 at 95% confidence. So I'm 95% sure that, well, the grade should be between this range. So what the point of doing that? So the point, I don't assume anything for that part, but using this range, again, the whole process is I have the entire jungle, and then I take out a few sample, and then we're gonna have the ends and compute a statistic. Remember, whatever that we done on a sample, we call statistics. Okay, whatever that we done on the population, we call parameter. So the parameter meaning that we're gonna have the mean and standard deviation. Okay, for our class, remember, for our class, not for all the sections. They might cover more. They might cover, no, they cannot cover less because this is the least that we can do for chapter 9. So for our class that we only deal with this guy. So with this guy we call sigma. Another word for that is chapio, right? And this is what my student actually told me what it is. So on the final exam for chapter 9, this number will be given. This will be given. Remember, this will be given. There's no way that they do not give you that part. So you have to look for this letter. So this number is known. So we know that if the sigma is known, what's happening? So then we have to use the z-score, correct? We have to use the z-score. Yeah, this is the thing that we have to do with. Another word for that, then we have to use the z-test. How many tests do we have in statistics? There will be so many of them. But this is the first test that people develop in statistics. Okay, so after that, we have the grandchildren model. We have a t-test developed by an Englishman. We have a chi-square test developed by Poisson. And a lot of the statistician, I don't know the name, so I only know that the work that they have done in the past 60 or 70 years. So what's going on about this guy is after we develop the confidence interval, so when I tell that the average for all the BCC that is spouted between 78 and 85 in the final exam, what does that tell us? So at 95% confident, so I can tell that the mean can be 78, right? The mean can be 79, the mean can be 79.1, the mean can be 80, the mean can be 81, the mean can be 82, the mean can be 83, the mean can be 84, right? So, or the mean can be 85, but the mean cannot be 86 based upon the data set that we have right there, right? So in fact, do we know the actual means on that example, the actual average of the final exam? We don't know yet, but the information that tells us is that I can tell you that the average on the final exam should be about it. So the 78 should be the C plus, right? And should be bounded between C plus or B plus, right? So B plus, no B, yeah, B or B plus, whatever it is. So I don't know. So 85 should be B or B plus. If you get 85, you get B plus. So, but if you get less than 85, you get the B. So generally, it should be bounded between C plus and B, right? For example, right? But we don't know what the average looks like for. We don't know if the average actually equal to 80. We don't know if the average that is equal to 81 or 82. But I can tell you, this is the bad that I got the information from the sample on the population model. So what's going on? We cannot test the equal size. So if you put that, can I assume that the mean equal to 79? That doesn't make any sense because I don't know the actual value for that. So we cannot test on that, right? So, but can we say if the mean is greater than 77? Yes and no. So you know that the mean range is about between 78 and 85. So I can't tell you that for all the business students who taking the final exam actually have the average greater than 77. The answer is yes, right? Because it's right there, right? So on this part. And can we tell that the mean actually less than 90 points? So that's pretty obvious, right? Because we know that the average, basically the maximum average, basically 85. So it should be good, right? But can we say that if the mean actually greater than 80, can we say that?
No.
Yeah. No, because the
Yeah.
mean can be 78, the mean can be 79. the mean can be 79.9, right? So we don't know that, right? So within the
Okay.
bound, within 78 and 85, we cannot conclude anything. But out of the bound, so you can see it out of the bound, I can confident tell you that the mean actually greater than 20. I mean, that's pretty obvious because 20 is go out of the bound, right? The mean, that's obvious. But doing the mean greater than 20, it doesn't really tell us anything at all, right? So everybody knows that. Even 5 years old kid can tell you that the mean actually greater than 20, right? So can you say the mean? Should we test on the mean greater than 0? The answer is no, because everybody know when you do the exam, the minimum score we got will be 0, right? So we're not gonna do something, let's say, meaningless. So meaning that we're trying to use the sample information. So most of the thing that's the statistician they do is that they use the sample information and they hypothesize. They hypothesize the average such that the number that is close to the sample mean. And then we develop tests along the way. So we're not going to test on the mean is actually greater than 10 or 20 or 40, even 50, because it's too far away from that. I mean, I can say yes, the mean's greater than 50 for sure, but I mean, it doesn't really tell me anything. So 50, do I know if all the students pass the final exam? I don't know. Do I know if the range people doing pretty well? I don't know. Greater than 50, it can be 51, it can be 52. But if I set up the mean, I want to test if the mean actually greater than 76, then there'll be some story to tell, right? So if the average greater than 76, if I say yes to that part, meaning that most of the students did pretty well, they all passed the test, the majority of the class passed the exam, and they're doing around that range, right? So setting up the hypothesis is not an easy task. It requires certain rejections or acceptance for that part. So generally, what we need to do in statistics will be the following thing. Okay. So so let's say we're gonna have a certain thing like that. Okay, so I don't know what it is. So this is what we call the grandpa model that we have for the Z. Why we can draw out this model, because based upon chapter 7, this is the Z test when we know the standard deviation. So this is the bow. This is between 75 and 80. I'm sorry, 78 and 85. I'm sorry about that. Meaning that, so within this bow, we cannot conclude anything, right? So can we test on the mean different from 79? No, the mean can be 79 at this point. Can we test if the mean greater than 81? No, the mean can be 70. So it can be 79, right? So it cannot be greater. Can we test on the mean less than 80, 82? No, the mean can be 84, right? So within this region, our decision will be conclusive if the sample statistics fall within this region. So meaning that our conclusion would be inconclusive. Okay, we cannot make any decision based upon that. So this that we learned from chapter 8, this is what we call what? Confidence interval. This is basically make the statistic ambiguous. Okay, so we know the range, right? We know the range, which is 78 and 85, but we don't know what the exact value that lie between 78 and 85. So this region that we call inconclusive region. So another word for that, which is called acceptance region for that, but I will let you know what it is. So within these two regions, right? So these two regions, what is that? This region that we call critical regions, or which is another word for that is extreme regions. Okay, it's critical or extreme regions. So unlike the English part, that critical means something really serious, but yeah, this is where we're going to say yes. We're going to say yes to our decision, meaning that our hypothesis is testified, is clarified. Okay, so meaning that we accept the thing that we assume. Okay, so our decision will be conclusive. Okay, conclusive regions. So, and then now we're gonna go to another thing, which is called the alpha. What is the alpha? The alpha is literally the thing that we call level significant. So why do people use the word level significant? Because it's important. This is where we're going to say reject or accept the claim. So the alpha that we're going to take would be around 5%, 10%, and 1%. So why are we using those values? So if we take the alpha equal to 5% statistic, remember, it depends on the purpose of the study. There will be some study that only require not the maximum accuracies of the report. So I can take the alpha equal to 10%, meaning what? The decision that we make will face 10% chance that is incorrect. Okay, so meaning that, so if you make this and say yes to the report, we have 10% chance that our decision will be wrong. The same
I have
thing.
a question.
Yeah.
Sorry. So the level of significance, that's pointing to everything in the chart, or?
Oh no, it should be depending on the purpose of the study and the statistic, but that number should be given on the question of the exam.
Okay.
That might give you 5% and 1%, 10%, but I'm trying to tell you the difference between those different extent values or intensity of the value for that part. So there's nothing wrong taking alpha equal to 20%, but if you take the alpha equal to 20%, the test might not be valid. Okay, the validity of the hypothesis testing depending on the change that you make the least error. You see what I'm saying? So let's say we take the alpha equal to 1%, meaning what? So we're gonna get 1% chance that our decision will be wrong. So 99% our decision will be correct. So the test will be very valid. You see what I'm saying? If we take the alpha equal to 50%, what the point? So meaning that our decision will be 50% correct and 50% wrong. It's just go against about statistics, right? Because we're doing a sample.
Yeah, you might as well guess at that point.
Right. So we're trying to get to the point where people are going to accept the hypothesis with the minimum doubt. You see what I'm saying?
Yeah.
But sometimes there were some tests that does not require a very accurate decision for that part. Sometimes we can take 10%. So if that is not super important, and sometimes we can bear. So this is called the certain extent that we can bear, a certain level that we can bear with the error. Okay, so some people might be able to bear with 10% error because okay, so my test I don't have enough resources, and then the test might not be extremely critical, so I can take 10% alpha. But if I want to make sure that, okay, I'm doing some chemistry reactions, so I can bear with 5% chance, so I can take alpha equal to 5%. So there were some like super important that we regarding the life-saving strategy. So I might use the alpha equal to 1%. Just want to make sure that everything worked well. It's just 1% alpha correspond to 99% confidence, right? So that's pretty much the thing. So the alpha basically lie between those tail regions that you can just check right there. So let's say the tail is, what is the tail? So let's say the mean is greater than 77. So 77 should be around this one, right? So it should be go out of the bound between 78 and 85. So this is where we just make our decision conclusive, right? So this is the thing that we need to do. Anyhow, and how many steps do we need to put them down? So there'll be a couple of steps that we need to do on the final exam. The first step that we're going to state the hypothesis. So it's stating the hypothesis is really important, and it's also very easy to get the point. There'll be two hypotheses. The first one is going to the region 70 and 85, we call no. The no region meaning that it's going to make our decision inconclusive, that we cannot really say anything about that. So the no would be HO, and then the H1 would be the alternative hypothesis. This is where we're trying to make our decision testify. We're going to making sure that it is on this part. So HO would be on this region. HO would be why people put down HO? Because we're gonna very likely that we're gonna have like a certain percentage that we're going to we cannot get our assumption testified. So HO basically represent these regions and H1 represent the alpha regions. Okay, this is where we're gonna get our decision testified. So how are we gonna write down a hypothesis? Very likely that we're gonna dealing with the mu. So for those of you who are not very used to how do we call this? The mu, right? This is one of the Greek letters. If you ask me how to write it down correctly, I don't know. I just put like letter U and then have some dash on the bottom. And this is how I write it. You can see how I write this. I don't even know how to write that correctly. So if you prefer to do with the M, letter M, you put them down on your work that you show on the final exam, I perfectly accept it. Okay, so you're gonna put them down. The first step, you put down the mu. So what is the null hypothesis? So this is what we call the null hypothesis. Let me just put in that right here. NULL. So the null means something that we try to negate, right? We try to get rid of, right? We call null hypothesis. But this is the part of the region where we're gonna make our decision inconclusive. On the other hand, the alternative hypothesis. So that would be the regions where you're gonna make it on these two regions. So when it fall within these two regions, meaning that we make our decision verified. So in other words, this is what I call alternative hypothesis. Okay, so it's go against those about 70 and 85. So the whole point is that this actually coming from the question. This is what we're trying to claim. This is coming from the claims, from the claim or the questions, the question being asked. So the keyword for that, you see what the keyword is. So let's say I want to test if the average on a second exam that is greater than 76, right? So we're gonna put down the goal of the test on the second hypothesis. Remember that we have to put them down. That part, if you pick alpha equal to 5%, you're gonna get 5% change. This will be correct. If we put down the alpha equal to 10%, so that will be 10% change. This will be correct. So as simple as that. But I mean, it's not as simple as we sound, but this is pretty much the easiest thing that we can think of. All right. So the second step will be.
Oh wait, I have a question. I mean, so I'm sorry to go back, but on the other side, there's an X next to mu less than 80. That should be a check, right?
No, greater than 80. Greater than, no, even if you put down the mean less than 80, that should be the not a check, right? That should be wrong. Either way, it is wrong, because how do you know if the mean's less than 80 on this part? You think of it. The mean can be 81, the mean can be 82, the mean can be 83, right? So there's no way that we can claim that the mean less than 80, right?
Okay.
So,
okay, I got it.
So we cannot claim on any values. So if you take the value equal to 82, how do you know if the mean greater than 82 or less than 82? There's no way. So the mean can be any value between 78 and 85. So that's a reason why any value that we set up, that we assume on this thing will be invalid, will be inconclusive. That we can't say anything about that. So that's a reason why we say the region will be called inconclusive region.
Okay, I just wanted to make sure I had that down.
Yeah, So it's better for our understanding for those of you who are taking intermediate statistics. If your professor is using that strategy to explain to you, that would be really great. But what I'm saying, I mean, we have different way of explaining it. But what I'm saying is that if you only just state hypothesis, just do the work without explanation, that is really hard to bear with. Okay, I mean, so, and also this is a very difficult topic. It's also the last topic of before the final exam, so that should be the hardest chapter. But again, I still insist on the hardest chapter in chapter 5 because it's all probability, and then probability is hard. And I mean, do we use probability on this chapter? Yes, we have 99% chance it's coming for the probability concept. But now the next step, we're gonna compute the statistics. Compute the statistics. This is also another thing that we need to do. So what statistic that we have to do? So the statistic that we need to be doing on this chapter will be the z-test. So what is the z-test? All right, so the z, I would let you know the form. It's basically the same form that we use for chapter 7, or we can also have the t-test and so on and so forth. But again, the t-test, when we have given by the snack, by the sample standard deviation S, then we're gonna deal with the t, but we're not gonna cover that part. Okay, so what is the statistics? So the statistic will be coming from the information that we collected from a sample. Let's say I took our class as a sample, unbiased sample, for example. I know our class is biased, but I took the class as a sample and computed average, a computed standard deviation, and so on and so forth. So all that will be called statistic. We will be called computing the statistics. Okay, it's based upon the sample information. So that will be the step number 2. After we finish the step number 2, then we going to compute the p-values, or the critical values. So since we not going to deal with the critical values because of the times, that not allowing us to do so, so we only stick with the p-values. Okay, so what is the p-value? The p-value is the probability that go with the statistics. Okay, so the p-value is the probability that go with the statistic. Let me just redraw this. Okay, so let's say if my p-value is actually very small, so it's basically going into that extreme value. So remember, the p-value should be very, very small. If the p-value, the probability that we computed is really big, for example, so it's including all the entire region right there. So if my p-value coming from a sample statistic is coming from the sample, remember those p-value will be the probability that coming from a sample that is relatively big, right? So for example, I compute a p-value on this side is big and it's fall within the the inconclusive regions. What's going on for that part? We fail, right? We failed hypothesis testing. Right? We're trying to, when we do the test, again, we cannot change those data sets. So what we're trying to do is that we want to test. You throw in current hypothesis and something good, we take it, something not good, out, right? So if the p-value that we computed is fall within the inconclusive region, then we cannot use this hypothesis. You see what I'm saying? So so we're trying to make sure, so the p-value will be computed based upon the sample. And then we're going to use the sample to test using the level of significance.
So is it like the p-value has to be in the critical range, and if it's in the null
then
hypothesis range, it's not valid?
Yes, it's not. I wouldn't say the word valid, but I would say it will not.
Like not useful?
Yes, not be useful. The hypothesis not be useful. So let's say we're going to compute a p-value will be very small. Let's say 0.00 something is fall within this range or that range. So that's good enough because those are the critical value that we can verify the result right away. You can see that can we say the mean greater than 77? It's actually fall within that one, right? So we say yes. Can we say the mean less than 90? The answer yes, we can fall within those 2 ranges.
Mm-hmm.
But if we get in a p-value that is relatively big enough, for example, let's say 20%, that's crazy. So 20% meaning that it's go around maybe 80 points, yeah, exactly 80 or maybe 79. So that might not be helpful. We cannot conclude anything for that part. So our assumption is wrong.
Okay.
Okay, so the p-value, basically the probability that go with the statistic that we compute on step number 2. The critical value is the value that go with the alpha, but we skip this part. And then we still have to compare them later on. So we use different strategy, but different approach, but basically the same concept. We have different approach with p-value and critical value, but they have the same concept. But generally, we skip the critical value. You can learn it, the critical value that can be learned. So this is what we learn it. So the critical value approach, pretty much the same thing, but I skipped that part because it's just complicated. So the decision rule, we're gonna stick with the p-value generally. Yeah. It's not bad, but it's just something that I don't want to spend too much time working on it. So after we compute the p-value, so the p-value usually with respect, so the p-value is the probability that go with the statistics, right? With the statistic, with a sample that go with a sample, with the sample information, right? So, and finally, that we're going to have to write down a final decision. So you need to compare them, right? So the final, you need to compare the p-values or the critical values to the statistics, or the p-value to the alpha. It's up to you. So compare the p-value to the alpha. How can I write down the alpha? I can't. I do not have the letter alpha. Okay. So I'm gonna just put that, compare the p-value with the alpha. So what's the alpha? The alpha is the error that we're going to set them up, right? So if you want our test to be very, very good and valid, I take the alpha equal to 1%. But if you don't care too much about the error bell, so we can take the alpha equal to 10%. So, and then before we can say, compare the p-value to the alpha or the critical value to the statistics that we have done to make a decision. Okay. So can we say our decision will be 100% correct? No, the decision that we have to be associated with the alpha. If we take alpha equal to 5%, so our decision will be 95% correct. If I take the alpha equal to 1%, our decision will be 99% correct. So that's pretty much that we're done. So let me just write out a step and how to get it done, right? So the concept is important, but I believe getting a good grade is more important. So step number 1, again, that we're going to state the no hypothesis, state the hypothesis. So on the exam, how many points do we do? How many points if we do that? We're going to get around 4 points on the final exam. So how can we state a no hypothesis? We just put down HO. If you read another book, you use H1. HO and H1. And so how can I put them down? So the first step, you're gonna put down the mean. Okay, so the mean equal to. So usually it's not equal. This is just for a very elementary level, but since we just stick to that, it's actually not. I just want to make the class easy. Nobody can tell you that your hypotheses are wrong when you put them down with the equal sign, but it just not right, right? It doesn't mean that it's wrong. It's just not right to say that. So the equal is, but usually that we're gonna put the opposite side for the H1. So the H1 is something that we try to test. This is what hypothesis that we assume, right? From the questions, the question gives the keyword from the questions. From the questions, okay, and so usually that would be 3 side, less than or greater than. So we can look it back to our examples. I can take the mean less than 90 or greater than 77. Can I test on the mean different than 86? The answer yes. We can also say yes as well. Let's go out. We can test on the different as well. But the difference would be 212 is pretty complicated. So remember that the less than or greater than would be the one-tailed test. One-tailed test is literally one-tailed. So this is what we have for the left tail. We test on the less than. So the less than means that the value have to go to the left side, right? And then if this side is greater than, so that would be the right toe. So this is what we call the left toe, and this is what we call the right toe. Okay, so this is the right toe. Okay, so we have a different. The different is, what is the different? Different meaning that it will not be less than, it will not be greater than. So use two of them. So we call it two-tail, right? But we skip that part because the reason why we need to skip that part, because when you read the note, if you don't read it, that's fine. Then when you look for the p-value, the two-tail test, you have to multiply by 2. It's just harder. I don't want you to do too much work for that part, so I skip them. You know, so I mean, there's no way that we skip that, but just want to make sure that we understand what it is. But we're not going to see them these questions on the exam. But what I'm saying, so I can test. There's nothing wrong testing the mean different from 86, right? So it's correct because the mean that we found from 78 and 85 that should be different from 86 for sure. So usually we need to write them down on the first one should be mean equal to something. Remember, this will be given on the questions. And the second, yeah, from the second one. The first one, just put down the equal sign, the same number, remember. And then the step number 2, that we compute the statistics. So step 2, compute the statistics. Again, that it is just something that we just did earlier, but what is the formula that we need to do? So the formula is z equal to, I believe this is what we learned. This is basically the most important concept from chapter 7. This chapter 7 was something that we started with the statistics. So we subtract the mean, and then we divide it by the standard deviation, and then we multiply by radical n. Right? We've seen that from before, from chapter 7. And this is the thing that we actually have to do it on chapter 9. Pretty much the same thing. And now we're going to do the step number 3 that we, after, I mean, do we only have one single formula for the entire statistic? No, there are like 1,000 forms that we use, but this is one of those, right? This is the thing that we're responsible for. Step number 3, that we compute the p-values, right? P-values. What is the p-value? So compute the p-values. So the p-value is using the information. So let's say, again, that using the calculator that we can verify the results, right? You can verify the result. And then we use that result to do the p-value. Remember that the p-value is based upon the p-value is the probability that goes with the sample information. Is used to sample, right? So we have to remember this. The statistic is basically the sample information that we got from. So we're gonna take that sample. We take the z-score, just like we convert to the z-score that we did on chapter 7, and then we view the p-value. So the p-values, would be equal to the probability of the z. So if this is on the left tail, that would be less than, right? If that is on the right tail, so let's say greater than. So let's say we see that it is greater than 80, greater than 77 or greater than 76, then we basically going to do with the right tail, the greater than. So how can we compute that? So the z-score, when it comes to the z-score, which table that we use? When it comes to the z-score, that we definitely going to use table number 3 or 3A, correct? That's obvious because it go with the z, right? Table 3 or 3A. So the p-values that we can use table 3 or 3A to verify the results, table 3 or 3A. And make sure that we're going to convert it to percentage later on. Finally, so that would be the last step that we need to take, the final step that we call step number 4. And we're going to conclude or make a decision for that. Make a decisions and a conclusion. So this is, we want to see whether or not it is inconclusive or conclusive for that part. So all we need to do for this part is we're going to compare the p-value and the alpha. If the p-values, remember you have to write down a p-value. If you forgot the word value, I don't know what it is. You just write out a p. I thought it was something from the alien numbers that you took from. I don't know. So you have to put in there p-value. If the p-values less than the alphas, So so this is, what is the alpha? If the alpha is given, remember. So what can we say? We're going to, if the p-value less than the alpha, we're going to reject h1, ho. So you reject the wrong one and then you accept. And so meaning that our claim was testified, okay? So reject ho and accept h1. We don't try to memorize the rule completely, but what we're trying to do in this case is that we stick with the claim. So our claim is correct. For example, I give you that information. So can we say that mean greater than 77? Yes, because it's basically full out of range. So our claim is correct. So in this case, we can say that the claim is verified. Okay. We accept h1. So remember, the no means something that we're trying to reject. If the p-value is greater than the alpha, right, it's greater than the alpha, since I don't have another. Okay, so what's going on for that is we don't use the word accept HO because we cannot accept the wrong hypothesis generally, but just want to make our class simple, we use the word accept. Usually we use the word do not reject or fail to reject. We don't use the word accept, but generally this is the case where we're going to do so and reject H1. Okay. So accept HO. Remember that usually we can't accept the wrong thing, the no hypothesis, right? The no meaning that something that we try to negate, we're trying to get rid of. But the fact that we accept the wrong thing, meaning that our claim cannot be verified.
So, like, let's say in a more advanced class, what would they call?
I'm sorry?
Rejecting H1 and instead doing something with the null hypothesis. Like what like term would they use?
Usually you don't have to write both of them. Sometimes you just say, so if the p-value less than the alpha, we accept the claim, right? We accept H1, that's it. You can just say,
okay. Or
if the p-value greater than the alpha, then we reject this guy. We reject the claim. So we reject the hypothesis. So the claim cannot be verified. Simple as that. Why the p-value greater than the alpha we reject? Because the probability represents the area on the curve. So the area is big enough. It's basically go to the inconclusive region. So we cannot accept the claim. So we have to reject it.
Okay.
For example, in this case, I can clearly see that the mean is less than 80 or greater than 80. Any number that go within this inconclusive region will be out for sure, 100%. But so this is what we can say about that part. So a claim cannot be verified. That's it. We finished the entire things. Okay. So now we're gonna. That's it. That will be the entire chapter 9 concept. This concept will be used for anything, for any statistics testing. But remember that we only doing a very little sense. We skip a lot of steps. We skip the critical region. Critical value approach, but they basically working in the same concept, right? The concept is here. So if you have a change to take the upper level of statistics, they work exactly the same way. For any statistic test, so you can have a t, you can have a chi-square, we can have the exponential, we can have whatever it is. So all of that. So anyhow, we're gonna do some practice and then we call it a day. So we're gonna do 2 problem. Okay, so we're gonna do 2 problem. Which problem should we do? Okay, it seems to be a very interesting question. It's question number 5. Why question number 5 is a very important problem? Because I haven't slept for 8 hours for so long. So I want to see if I can sleep for 8 hours. Okay. So let me just check them and make it a little bigger. Okay. Even highlighted, is that even better? Okay, so we claim the adults, do we sleep more than 8 hours or less than 8 hours per day, per night? I don't know. Usually I sleep on average 6 hours per day, per night. I'm sorry, per night. For
I definitely get 8 hours.
You know, yeah, actually this time. That is true.
That's
But I
good.
mean, normally without the outbreak, so I would expect that not just
Yeah, I get 10 hours.
10 hours. That is better. It's really good to hear from you guys. Well, I did not study biology, but from the biological perspective, so people are saying that and when you sleep too much, it's not good. But I'm not sure with that because I trust statistic. I don't trust a number. I'm sorry, I don't trust the advice generally. So anyhow, do we have an average of 8 hours of sleep? The answer is I don't know. So we need going to highlight a thing. The standard deviation is 2.1, right? So this is all we need to do on the final exam. Just do me a favor. Do not rush on the exams. We have a lot of time to do 1 questions. And the sample is 20 adults, n equal to 20. And we also have the x bar equal to 69. This is all we need to get. Right? What else do we need? So we need the x bar, we need the standard deviation, we need the n, we need the mean and the alpha, right? So how do you know it is the alpha? So the alpha will be followed by the keyword. You know what the keyword is? Level of significance. So this is the keyword that we're going to put them down, and we call it, this is the alpha. So this will be the alpha. And what is the keyword for this question? What are we trying to test? We want to know if, on average, that people sleep less than 8 hours per night. So this is what we're trying to test for. Okay, so this is what we have for the mean. You want to test if the mean actually less than 8. Do we know is specifically is 8 hours sleep? No, we don't know that yet, but we try to test on that because most of the recommendation from the doctors, pharmacists saying that, well, we should maintain the 8 hours sleep, but we're not sure. We want to see the sample and whether or not we can claim that result. So the result that we try to claim will be less than 8 hours. So we have the n equal to 20, right? We're going to put that first, the information. Do we get point deducted if we don't write down the information? The answer is no, but I believe it is some point because when you put down the information, we cannot miss any number. And the next part, we're going to put down the sigma, right? The choppy on that we have here, that'll be 2.1. And for the next step, we're going to put out the x bar. So that will be 3.9 hour. So that will be 3.9. And then after that, we're going to put down the alpha. So the alpha is 5%. The alpha is 5%. Okay. So how can I get the mean? Some of you might be asking, hey, we need one more number. We need the mean. But do we actually know the mean is? The answer is no. This is just coming from the hypothesis. So what the hypothesis telling us is that I want you to test if the adults actually sleep less than 8. So this is what the mean, 8. Okay, 8 will be the mean. So now we're gonna follow the hypothesis. What is the hypothesis? Remember that we have to write 2 of them. The first will be actual. the second will be H1. Remember that. So if you miss any of them, you're gonna get some point deducted. If you miss the first one, I'm gonna take away 2 points. If you miss the second one, I'll take away 2 points. So if you miss all of them, I take away 4 points on the final exam. 4. This question is 4 point. I kid you not. Just write them down. Very simple. So how can I write them down? The hypothesis. You can put down the mean. Right? You're gonna put down the M. You're gonna put down the letter M first. Very easy. Do not put down X bar. You put X bar, you don't get point. You put down the M first. Okay. The 1 is equal. And what is another one? How can I put that above the bottom one? The bottom should be followed from what we're trying to test. This is what we assume. So this will be on the keywords, right? Coming from the keyword, the H1 that we can see that less than 8, so we put down the mean less than 8 hours. The top is equal to 8 hours. Are we good?
Yes.
Are we good for that? Just put down the means, and then followed by the keywords. The keyword is less than 8 hour. So, and then I just put it less than 8 hour. That's it. And this is the lab tell, right? This is the lab tell test. Lab tell. So, are we good? And how many points on these questions on the final exam? So this question will be 4 points. By putting down H1, the mean less than 8, the mean equal to 8. I mean, the first one will be equal. The second will be either less than or greater than. Or different, but we don't do the different. So step number 2 that we need to do the statistics. That will be equal to, that will be the Z equal to the X bar minus the mean divided by the standard deviations. Okay, divided by standard deviations. Here's the radical n multiplied by the radical n. Okay, so the same thing that we did from chapter 7 that we're gonna take, open the parentheses. The mean that we found is 6.9 and minus the mean. What is the mean? What is the hypothesized mean that we have is 8 hours. So I want to test if the people sleep less than 8 hours. So that would be 8. And then we divide it by the standard deviations that is given equal to 2.1, 2.8. Okay. And then finally that we multiply by radical n is radical 20. So we multiply by radical 20. Okay, how can you do this computation? I feel like we are basically very familiar with that. Do we agree? And just open the parentheses. Remember, you have to open and close parentheses. If you don't open and close, you're going to get it wrong. So we're going to take 6.9 minus 8, and then we close this parentheses, right? And then we divide it by 2.1, correct? And then we multiply by second. We have to hit the second. If you don't hit the second, you're going to, remember that we don't hit the second, you're going to get the x squared. It doesn't mean anything. You have to hit the second, right? Hit the second. If you don't hit the second, you get something like that, right? So make sure they're going to hit the second and then square root and then put down 20 and then you click equal. Okay, so the answer for that is negative 2.34. Are we good?
Yep.
Yeah.
Negative 2.34. And I feel like I'm very happy using this calculators. So the next step that after we compute this, right? So we need to compute a p-value based upon the statistic, based upon these values. So so the p-values will be the probability, right, of the z. So now z is greater or less than. So you see, do we see the sign less than 8 hours? Less than, so that should be less than negative 2.34, not less than 8. Negative 2.34, the statistic that we converted to the z-score. We do pretty much the same things at chapter 7, right? And then, so remember, less than 8, so you have to put down, this one is less than negative 2.34. So how can I find the z-score of negative 2.34? So we have to use table number
Wait, sir, in this case, the Z is 8, right? That's why you put less than the negative
No,
0.34.
the reason why this is less than because the keyword less than,
Okay.
right? Because the keyword less than, so we have to work on the left toe. So the left toe should be this side. We work on this side, not on that side. We have to work on this side. So the left toe. So we have to. So the probability have to go to the left, right, instead of going to the right. So remember, the p-value, they probably have to either go to the left or the right, depending on the side of that part. So we go to negative 2.34, 2.34, that divide the values, which is negative 2.34. So the value that we found is 0.0096. Do we have to subtract from 1? No, right? We don't have to
Nope.
subtract from 1 because the sign less than. And if we want to convert to percentage, what should we do? So we're going to take 0.0096, we multiply by 100, correct? So we convert it to percentage. And what do you think? So this is 0.96%.
6%.
0.96%. Are we good?
And looking for percentage is a must in this topic.
I'm sorry, I can't hear you. I'm sorry.
Converting for percentage is a must, right? That's the end product, the end answer.
Yeah.
The final answer.
Yeah, so the p-value, I mean, usually people don't want to convert to percentage, but I would tell you why, because we have to get the answers. You don't have to. I mean, if you see that a different, which one is smaller, you compare the p-value and then the alpha. So the alpha is 0.05, the p-value 0.0096. If you're good at math, you can see that the p-value less than the alpha. So the whole reason why we convert to percentage, because when I compare the p-value and then the alpha, I can see it clearer. So this is less than 1%, right? 0.96%. So this is 5%. So 1% should be less than 5%. So we're done. You don't necessarily have to convert to percentage. I usually don't take weight points, and I usually don't do that. But I learned from my past experience saying that people, we have some we have some situation where people have trouble converting, reading the decimal number, and sometimes we don't know which one is greater, which one is smaller. So I would convert to percentage and see it immediately. So after we get the p-values, and then we compare with the alphas, and then apparently that the p-value that we found is 0.96% is less than 1%. That should be less. Remember, the sign less than should be like this one, right? So this is, we call less than. So the other one is greater than is different, right? Less than the alpha, so alpha equal to 5%. And apparently this is the word. So remember, less than is this side, greater than is that side, and make sure that we don't mess that up. So
if it's greater than, do we gotta subtract it before we do that part?
Depends. Yeah. So if the p-value, so if the question asking at greater than 8 hours, so that have to be 1 minus something that we read on the chart. It's the thing that we learned from chapter 7. For example, if they want to figure out the probability of z greater than 1.5, of course you have to read it and then subtract from 1. So I'm gonna go torch you that example later on. So so now if the p-value less than the alpha, what's going on for that part? Is the p-value less than the alpha? So the alpha is set up right there. So the p-value, the statistic that we found is going for that regions, right? So the region where I can't verify the claim, I can basically conclude that. So meaning that we sleep less than the hour. So in other words, for that, if the p-value less than the alpha, what can we say? We're going to reject HO, accept H1. So we have to reject this guy, right? And we say we check for this part. Correct? So we reject HO and accept H1. Oh, you can simply say you reject HO, or you can simply say accept H1. That's it. But I just want to make sure that people understand when you reject one thing, then you have to accept another. Okay, so usually that you don't memorize both of them. Don't make your mind complicated. Don't make my work complicated, right? You can just write them down, reject HO. That's it. I understand it. Okay, but when I write them down, I just sometimes I want to make sure that we understand why do we need to have two hypotheses, meaning that we cannot reject both or accept both of them, right? So if you reject HO, meaning that you accept another one. So I reject this, we accept that. So when we accept that, what does it mean? Our claim is verified, right? So what does that mean for that? So I can't copy for that. Okay. So our claim is verified, meaning that I can't 95% confident because the alpha is 5%. So 5% chance that I'm going to make an error. So we claim that we are all sleeping less than 8 hours. Okay, I'm scared. Just the population itself, depending on how big of the population, the populations. I don't know what the population that we took, maybe for the entire United States or for the whole world. We claim that the population is sleeping sleep less than 8 hours per night. Sleep less than 8 hours per night. And that's it. Okay. We claim that. Our claim is verified because we reject each other. If the p-value greater than the alpha, so we can say inconclusive. I need to get rid of that hypothesis. So I maintain that hypothesis because of the p-value less than the alpha. Even if I take the alpha equal to 1%, I still going to get my claim verified. But 5% is good enough at 5% significant level. Level of significance. Okay. All right. So I feel like the question was done. Right, and can I move on to the next question?
Wait, sir. Can you write down table 3?
Table 3. Oh yeah, I should. I forgot it. I apologize. So yeah, so this is so we see that this is the z negative, correct? So the z negative, then we have to use table 3. If the z is positive, then we have to use table 8, correct?
Yeah.
And how did we take this value? So this value is basically coming from this guy, right? From the step number 2. And we just compute it. Okay, so we're gonna take that values coming from, you can't just randomly pick the value and then do the statistic. Remember, the p-value would be the probability that is associated with the sample information, with the sample that we computed. I think I put them down, right? And the p-value is, okay, so, and making sure that we understand what it is. All right, so I feel like that's pretty much it. We agree. And why don't we do another example and see how it looks like? Which example should we do?
Right tail.
Right tail. More than, okay, more than is right tail apparently, so I can see the keyword, take that example. Yeah, right tail is more than, right? Greater than. So, and I'm gonna download it. I know what the question looks like. I don't even have to read the question. I mean, this question just specifies, this is what I usually do on a final exam. So I put down part A, determine a null hypothesis, and part B, compute whatever it is, and part C, compute a p-value, and part D, what is the decision. You must justify your answer. You can't just like, whoa, I say yes. No, you have to do statistics, compare the p-value and then the alpha, and which one is the. Usually you don't have to leave at a decimal number, to be completely honest. It's easier to look at the p-values and the level of significance in terms of the percentage you compare the values. And so I would say this is question number 7 on the list. And that's pretty much the thing that we need to do, and we just go for that part. Let me highlight that a little bit and make it a little bigger. And what else do we need to do? And I'm going to highlight the word for that, right? So
the word that we need to highlight will be the standard deviations, 3.2, right? That is given. And we also have the X bar equal to 12.1. And we also have the N equal to 22. And mean equal to 10 for sure. And we also have the mean equal to 10. And what is another information? Oops, I cannot make it straight lines. Shame. My handwriting sucks. My drawing skill sucks too. So don't draw so many pictures on a final exam. I get jealous. And the keyword for that is 10%. I'm sorry, is 10. More than 10 is greater than 10. So this is what we're trying to test, right? We're trying to test if the mean is greater than 10, right? So more than mean greater than 10. And the level that we took 1%. Wow, okay. We want to be very, very accurate. Why we need to be accurate? Because the minutes that we wait matter a lot, right? I don't want to wait so long, so I need to be accurate for that part. So the alpha equal to 1%. So this is what we have for the alpha. It depends on the need. There was a certain report that we don't need to have like 1% significant level. This is sometimes it's, I mean, there's nothing wrong taking 1%. There's nothing wrong taking 20%, but it's usually between 10 and 1% to 10% is good enough. So so we're gonna put down informations. We're gonna go with the N equal to 22. And we're gonna go with the standard deviations. Will be 3.2. And then we're gonna go with the X bar. What is the X bar? X bar is 12.1. And that'll be the sample average coming from the sample. Remember, a random sample, usually after word random sample will be the X bar. And why is that? Because X bar is the sample average, the average coming from the sample size. And then we also have the mean equal to 10. And then the alpha equal to 1%. So I would take the alpha equal to 1%. So it's really hard to reject this guy. It's really, really hard to verify the claim because we take 1%. 10% is easy, a lot easier. But 1% is pretty hard for that part. So we're gonna put down hypothesis, do we agree? So we're gonna go with the H0 and H1. Okay. So what should we write? We're gonna put down a mean. Correct, we're gonna put down a mean. The first one you put equal 10, correct? The second one we put greater than 10. Why do we have to put greater than 10? Because this is what we're trying to testify. This is what we're trying to verify our hypothesis. So I assume that the waiting times more than 10 minutes. That's crazy. I usually have to wait for 20 minutes. Especially during the outbreak. But okay, so this is the case. Then we call this is a right tell. Do we agree? Because its test on the right is greater than. So the step number 2 that we're gonna compute the z statistics. Okay, so what is the z statistic? We're gonna take the X bar minus the mean and divided by the standard deviation. And we multiply by radical n. Okay, so for those of you who feel like, well, can I follow this one instead of the font? Yes, the final, the formula package that we can see that for chapter 9 is what the z equal to x bar minus the mean over standard deviation divided by radical n. It's just make complicated, but if you guys used to it, that's fair enough. But if you don't get used to it, we just multiply by radical n. I feel like it's gonna be a lot easier to do the math because we want to do everything here at once. Okay, so in other words, what should we do? We're going to take open the parentheses. The x bar that we get is 12.1 minus the hypothesized mean is 10. Right? We don't know if, I don't know the actual average of the entire population of the waiting time for all customers, right, for all period. But we take 10 because this is what we assume. So 10 is coming from the question, remember. And then we divide it by the standard deviations. I mean, 10 actually people, the natural food, the advertisers, but they claim that the advertising is wrong. It should be more than 10, right? They advertise that the population in waiting time is 10. I don't trust that number. So I want you to test if the average is actually more than 10. So we divide it by the standard deviation 3. And then we multiply by radical. What is the n? So how many customers do we take? How many sample time?
22.
22 sample waiting times. And why always 22? Did the last question also 22? No, 20. Okay, so so now we're gonna take open the calculator. I'm gonna take 12.1 minus 10, close the parentheses for that part, and then we divide it by 3.2 and times the square root of 22, right? And then equal. So I got the answers with 3.07 or 3.08, doesn't matter. Okay, so I'm going to rewrite this as 3.07. Okay, so after that part, then we're going to compute the p-values. So what is the p-values? It would be the probability. So now, we see the size greater than, right? So we're going to put that greater than 3.7.
Yeah.
Because the size greater than is on the right tail. So we test on the right part of it, right? It's not going to be on the left part of it. So what should we do? We're going to go to the formula package, right? 3.07 is positive. Then we have to go to the positive z-score, right? Just want to make sure that we understand this. So this is positive z plus, right? And meaning that we go to table number 3, table 3A. Table 3A, and then we read that table, and we found the 3.0 actually really big, and 0.7.
7.
So that'd be 2 columns for the last one, right? So that'd be 0.9989. Let me just double check 3.0 column. And let me, okay, corresponding columns correct. Row and columns correct. So that'd be 0.9909. And so we're gonna put it down as 0.9909. Is that correct?
No.
No. What should we do?
0.989.
Right. So remember, the p-value is usually relatively small because we're trying to get the p-value that go to the regions for that part, right? So the p-value should be relatively small. So on the right, then we have to subtract from 1. So because the probability that we got basically on the left side, so we subtract from 1, and we do the calculator 1 minus 0.9989, and we got the answer, which is 0.0011. All right, is it correct? So 0.0011, I convert to the decimal number and multiply this by 100. I'm sorry, convert to percentage. I got 0.11%. So 0.11%, which is so much smaller than 1%, right? So which one is greater, the alpha or the p-value? So the p-value is 0.11 and alpha 1, right? So 1 should be greater than 0.11 for sure. So we can claim that the p-values equal to 0.11%, greater than, I'm sorry, less than, I apologize for that, less than the alpha. If the p-value greater than, then we cannot get our claim verified. Then we can't conclude that. So, but since is the alpha that we have is 1%, that is big enough, right, compared to the p-value of statistics. So meaning that our claim is verified, we reject HO, and we accept H1. If the p-value greater than the alpha, then we have to accept HO and reject H1. Oh, you just simply say reject HO, that's it. If you don't have to say accept H1. So meaning that this guy, and then so meaning the advertisement is wrong. They claim that the average time, I'm sorry, the average time that we have to wait is 10 minutes. That is wrong because I used 22 sample and I checked that, so it's actually more than 10 minutes. So our claim is verified. I mean, justify whatever you want. So I would say justifies because we do the work just to verify the result. But anyhow, so we're gonna say that so the advertising was wrong. Indeed, we wait more than 10 hours, more than 10 minutes at 1% level significant. That's oops. Oh, no, my goodness. I need to get rid of this part. Go back. I cannot go back there, but all right. So I'm gonna get rid of this. I'm running out of space, so I'm gonna put it that right here. So the advertising was wrong. Advertising was wrong because indeed we wait the population mean waiting times is more than 10 at 1%.
Do we have to write this sentence out at the end,
Well,
or we don't?
if you don't write them down, I don't take away point. But in order to answer the question, you have to state the answers, right? You have to state the verifications. What is that? So, what does involve rejecting HO? So let people know that. All right, because we want to make sure that the advertising was wrong. They just basically minimize the waiting time. We're not exaggerating to say the population waiting times on average that we should wait more than 10 minutes. That's 1% level of significant. Okay, so that's pretty much it. And I hope you guys have a great day. And I will see you guys on Thursday. Remember, Thursday we're going to have classwork and quizzes. And stay safe and stay healthy. And I'll see you guys.
Thank you, Professor. See you Thursday.
Thank you.
So both classwork is gonna be next week, right?
I'm sorry?
Both classwork is gonna be next week, right?
No, the next week gonna be the final exam review. So we
No,
everything.
I said we don't have a classwork today.
Oh, we do not have a classwork today. We haven't finished that yet. We need more practice before we can do the classwork. But generally, when we come back on Thursday, we're gonna have the classwork. Actually, 2 classwork for that, and then just do them, and after I can start a quiz later on. So, okay, the quiz also 24 hours, but you should finish it in 1 hour, and 1 hour. That should be 1 question only. Okay. So I hope that you guys going to stay well again and enjoy.
Wait.
I'm sorry. Yeah.
Steve said, can you go back the question 5, please? I just want to check.
5. Yeah. The same thing. So
I got it.
For chapter 9, we're only doing the Z, right? I mean the standard.
Don't worry about the T. The T we don't have.
We're not doing the P or the S.
Yeah. So we're gonna deal with the Z. This is something that we have right there. Remember that the lecture note is posted, right? So everything that we did in class will be posted right there. So you can double check the work right there. So you don't have to worry about whether or not I'm losing some files, whatever it is. Whatever that we do in class will be posted in Blackboard. So, all right. So I hope you guys are going to enjoy your day again. And see you guys on Thursday.
All right, bye.